Next, we have got derivative of sum rule. What is the derivative of sum rule? It is when we have got two functions added together. So if we've got f of x, that was the fourth rule, okay? If you've got a function f of x and a function g of x, if they are summed or subtracted from each other, how do we take the derivative of this one? It is easy. We are simply taking the derivative of f of x, okay? If it was the addition, we are putting the addition sign, and if it is subtraction, we are putting the subtraction sign with g prime of x. So when we have got two functions added together or subtracted together, we are simply finding the derivative of f of x plus or minus the derivative of g of x. For example, if you've got y is equal to x squared plus x. This is a function. Oh, of course, it is given as one function, but if you consider it in general, it is one function added with another function. So how do we take the derivative of this one? We're simply finding the derivative of this, that's equal to 2x, plus the derivative of this one, that's equal to 1. So simply we are doing that. If we have got subtraction, okay, if you have got x squared minus x, how do you find the derivative of this one? Y prime is equal to, again, the derivative of this one, that's equal to 2x, minus the derivative of this one, that's equal to 1. We've got an example, okay, example 3 in your lecture notes. It says find the derivative of y that's equal to x to the power of 3 plus 4 over 3x squared minus 5x plus 1. How do you find the derivative of this one? This one is that function that is given to us is given as a bunch of functions added and subtracted together. So that is one function plus another function minus another function plus one another function. So how do you find the derivative of this one? Simply, we are finding the derivative of this one, that's 3x squared, plus finding the derivative of that part. The 2 comes in front, so that will be 8 over 3x. The derivative of this one is equal to 5, and the derivative of this one is equal to 0. That will be, of course, vanished from the solution. Okay, so it is simple. You're simply adding the derivative of each term separately. Next, we are coming to the product rule. Okay, product of two functions. That was the addition and subtraction of two functions. This one is the product of two functions, or if you have got more functions multiplied together. Of course, if you've got a function f of x that is multiplied, look here, we have got multiplication, g of x, how do you find the derivative of those two functions together? That's equal to f prime of x, okay, I'm sorry, I wrote it there, f prime of x multiplied to g of x plus g prime of x, the derivative of g of x, multiplied to f of x without any change. So we were saying, how were we saying it in class? That was one function multiplied to the second function, okay? We were saying first one's derivative multiplied with the second one, okay? Plus second function's derivative multiplied to the first one. Okay, let's give an example about that. We have got in example 5. It says find the derivative of the function y that's equal to x squared plus 1 multiplied to x to the power of 3, or x cubed, plus 3. How do we find the derivative of that function? That one is the first function, okay, function 1, or we can say that this is f of x, and that one is the second function that we have got, or we can say that is g of x. How do you find the derivative of that function? Easy, depending on the rule. We know that if you want to find y prime, we say that first one's derivative times second one plus second one's derivative times first one without any change. What is the derivative of the first one? That's equal to 2x, okay? 2x multiplied with the second one, so that one is x to the power of 3 plus 3. We have got that plus sign here, so we have got that plus sign here. Second one's derivative, okay, the derivative of this one is equal to what? Is equal to 3x squared multiplied with the first one without any change, so that one is x squared plus 1. That's the first derivative of the function that we could find. Of course, you can simplify this one more, multiplying this one with that, this one with that, and of course this with those. 2x multiplied to x to the power of 3, that is 2x to the power of 4. 2x multiplied to 3, that's 6x, okay, plus 3x squared multiplied to x squared, that's 3x to the power of 4. Why? Because we know that if the bases are equal to each other, the powers will add, so that one is equal to x to the power of 4. And we've got here 3x squared multiplied to 1, that's equal to 3x squared again. How do we simplify it more? Of course, we are adding the like terms, the terms that are like each other. They have got the terms that have got the same power. We've got 2x to the power of 4 and 3x to the power of 4. If you've got 2x to the power of 4 plus 3x to the power of 4 is equal to what? 5x to the power of 4. We've got 3x squared here. We don't have any x squared, so we are putting it as it is. We've got 6x here without any other terms like it, so we are putting the 6x back to its place. So that one is what? That one is the derivative of a product. Product of what? Product of two functions. First we had addition or subtraction of two functions. We were simply taking the derivative of each term separately, and then we had what? Product rule. We are having two functions multiplied together and we want to take the derivative of this one. We've got that general rule. Next we have got quotient rule. What is quotient rule? What is quotient rule? If you have got two functions that are divided to each other from so sorry, I don't have f prime. We've got f of x divided by g of x, and we want to take the derivative of this one. F of x is any function and g of x is any function. They are divided by each other. If you want to take the derivative of this one, how can we find that derivative? We've got a rule. It says we are finding it as this: f prime of x multiplied to g of x without any change, minus we are finding the derivative of the denominator multiplied with the numerator without any change, all over denominator square. So we have got that rule for finding the derivative of a quotient function. We are given an example, example 6. It says find the derivative of y, that's equal to t squared minus 1 over t to the power of 3 plus 1. Of course, it doesn't make a difference if it is written as t squared minus 1 or x squared minus 1, and that one t to the power of 3 plus 1 or x to the power of 3 plus 1. It's just the change of a variable. It doesn't make a difference. So how do you find that derivative? Since it's a quotient function, so we can say that that one is the first function, okay, and that one is the second function. How do you find the derivative of this one? We know that if you have got a quotient function, that's equal to first one's derivative multiplied with the second one minus second one's derivative times first one all over second one square. That means the denominator square. So let's find it. That was the rule. First one's derivative. What is the derivative of that first function? It is equal to 2t multiplied with the second function without any change. So we are writing t to the power of 3 plus 1. We've got a minus. We're putting the minus back to its place. Second one's derivative. What is the derivative of that part? It is 3t squared. Okay, the derivative of this one is 3t squared and that one is 0. Multiplied with the first function without any change. So that one is t squared minus 1 all over the second one squared. So t to the power of 3 plus 1 all squared. That is the quotient rule. You can do simplification. You can multiply this one with inside and that one with inside. Of course, we have got the negative also to there. It should be multiplied to them. You're finding that multiplication, adding the like terms, and you will get the required result. That is for the rules of multiplication. So far, what have we studied? We have studied the constant function. If you have got f of x that's equal to a constant, how do we deal with it? The derivative of this one is equal to 0. Second, we studied the power function. If the function was given as x to the power of n, where n is a real number, how do we take the derivative of this one? The n was coming in front of the x and the power was decreased by 1. We had the constant multiple function. That was the multiplication of this function with that function or any other function. And we had the sum rule, sum or difference rule. It doesn't make a difference because they have got the same rule. Then we had product rule. Okay, if a function is multiplied to another function, how do you find the derivative of this one? And then we had quotient rule. If a function is divided by another function, okay, that one is f plus g, this one is f multiplied with g, and that one is f divided by g. Okay, that were the rules of differentiation. Now in the same section, of course, we have got second and higher order derivatives. Okay, we have got second or higher and not or. Order derivatives. How do we find the second derivative of a function or higher derivatives of functions? If you are given a function y that's equal to, for example, x to the power of 5, how do you find y double prime? Okay, y double prime is required from you. How do you find it? We are simply finding the first derivative of the function. So y prime is equal to what? It's equal to 5x to the power of 4. How do you find the second derivative? The second derivative is the derivative of the first one. Okay, so taking the derivative of this one, the 4 comes in front, that will be 20x to the power of 3. So we found the second derivative of the function that's equal to 20x to the power of 3. So how do you find the second derivative? It is the derivative of the function. That is the second derivative. How about the higher derivative of a function? If it is required from you to find y to the power of 4 in the brackets. Of course, when we are talking about power of a function inside a bracket, that means we are finding the fourth derivative of that function, not y multiplied to itself 4 times, because this one is different from that one. Okay, without a bracket, that means we are multiplying that function to itself 4 times. It becomes like that. Y to the power of 4 is equal to x to the power of 5 multiplied to x to the power of 5 multiplied to x to the power of 5 multiplied to x to the power of 5. If you see from here, when it doesn't have brackets, that means we are multiplying the same function 4 times to itself. But when it is put in a bracket, that means we are finding the fourth derivative, 1, 2, 3, fourth derivative of that function. How do you find the fourth derivative of that function? We know that the first derivative of the function is 5x to the power of 4. The second derivative, we are taking the derivative of this one, that is 20x to the power of 3. The third derivative, we are taking the derivative of the second derivative, 3 multiplied to 20, that is 60x squared. So the fourth derivative, either you're writing it like that or writing it this way, is equal to what? 2 multiplied to 60, that's 120x, and that is the higher order derivative. Okay, so if you have got second derivative of a function, we are just simply finding the derivative of the first derivative. If it is higher order, we are just simply finding the derivative of that function, this much that is given to us. That's all about section 2. Hope you have understood this subject well. And of course, if you've got any questions, haven't understood any example, or you're sending any other examples, I'll be available and be answering you. Thank you for listening. Have a nice day.